Today we are discussing molecular ion O2 minus. Two ways are there to explain the formation of molecular ion. First, I'll explain the formation of molecule, and in that molecule I will add electron if charge on the molecular ion is negative, or remove the electron if charge on the molecular ion is positive. Here O2 minus I want to discuss. So I can add one electron in the antibonding molecular orbital, last molecular orbital of the O2 molecule, and can explain the O2 minus. Or other way, I can consider respective species to result the O2 minus ion. Means I will consider atomic orbitals of oxygen one side and orbitals of O minus. So O and O minus will combine to produce O2 minus. Energetics of oxygen and energetics of O minus, orbitals of oxygen, their energy levels, orbitals of O minus, their energy levels will be different. That I wanted to emphasize. Let us see the establishment of various molecular orbitals for O2 minus.
Three essential compartments that generally we use to explain the molecular orbital diagrams for various molecules or ions are here. Left compartment is atomic orbitals of oxygen. Middle compartment is molecular orbitals of the ion under consideration. That's a superoxo ion O2 minus. And right compartment orbitals of ion O minus. My emphasis here is the energetics of the orbitals of oxygen and O minus ion. About oxygen, the concept is very clear to us. 2s orbital, there are 2 electrons, and then 2p orbital, 4 electrons will be there. I want to consider ion O minus. In O minus, how many protons are there? 8. Those are same as like the oxygen atom. But how many electrons are there? 9. Means number of electrons are more than that of the proton. So effective nuclear charge, effective force of attraction exerted by the nucleus on the outermost electron, where will it be more? Yes, in oxygen it will be more. So whose size will be the large? O minus ion size will be large. So where will the energy of 2s orbital low? In shrinked oxygen or enlarged O minus? Yes, in the shrinked oxygen, small sized oxygen. So energy of orbitals of oxygen are lower than energies of respective orbitals of O minus. It is because size of oxygen atom is smaller than that of O minus. It is because number of protons existing in the nucleus are same both where, but number of electrons are less in case of oxygen atom, and in case of O minus ion number of electrons are more, due to which the effective nuclear charge experienced by the electrons in O minus is relatively poor, increasing the energy of respective orbitals. So you pay the attention properly. Energy of 2s orbital of O minus is higher than that of the energy of 2s orbital of oxygen. Same is the case in case of 2p orbitals. So in such cases, if we have to establish the bonding orbital, then energy will decrease. Antibonding orbital, energy of resultant orbital will increase. Then from where we measure the decrease or increase? We measure decrease or increase from average energy. Means if I consider the formation of sigma 2s bonding orbital from 2s orbital of oxygen and 2s orbital of O minus, then decrease of 2s I have to measure from average line, average energy of those 2s orbitals. Similarly, increase in the energy of sigma star 2s we will measure from that average line. If you observe neatly, you will find energy arrow is represented left side. Let us discuss establishment of various molecular orbitals. If I begin from the 1s orbital, 1s orbital of oxygen, which is lower in energy than the 1s orbital of other species, that is the O minus ion, which is lower in energy, they will interact or not interact. They will not interact because those are inner, those are not experiencing any kind of appropriate sufficient interaction. So if there is no interaction, then the orbitals will remain non-bonding. So relative to atomic orbitals, their energy remains same. Overlap integral remains 0. But among those two non-bonding orbitals, which one s orbital from oxygen and one s orbital from O minus, we represent them as K. Why K? Because it is a first shell. So K of O minus will be of lower energy, or K of oxygen will be of lower energy? Yes, K of oxygen will be of lower energy. Then K of O minus will be there. Afterwards, actual our molecular orbital starts and those are represented there. Next higher energy level molecular orbital is sigma 2s, is bonding molecular orbital. Then sigma star 2s, anti-bonding molecular orbital. Afterwards, when 2p orbitals interact with each other, 2p orbital is a cluster. Internuclear axis we are considering as a z axis. So 2pz orbital will be with sigma symmetry, and 2px and 2py orbitals will be with pi symmetry. Sigma symmetry means symmetric about internuclear axes. If we rotate that orbital, there will not be any change in phase. 2px and 2py I say pi symmetric because if we rotate those orbitals along the internuclear axis, then the phase change will occur during rotation. So they are not symmetric about internuclear cylindrical axis, and we label them as pi. As per the second principle of LCAO, combining atomic orbitals should be of same symmetry. So I represented there two paired orbitals by yellow color, sigma symmetric orbitals, and 2px 2p orbitals by green color, pi symmetric orbitals. If we bring those two clusters together, then the orbital whose lobes are along axis, that orbital will experience more kind of interaction, more overlap. Therefore, we say sigma bond is stronger. If more interaction is there, then the stability of resultant bonding orbital, that's the sigma 2pz, will be more, and instability of antibonding orbital, that's a sigma star 2pz, also will be the more. So among the 6 various molecular orbitals which can be the result from the interaction between the 2p sets of two systems, we will find sigma 2pz is of lowest in energy and sigma star 2pz is of highest in energy. And relatively, pi bonding, interaction between px and px, py and py is a lateral interaction, sideway interaction, relatively poor interaction, will result bonding pi orbital and anti-bonding pi orbital sets. Bonding pi orbital sets pi to px and pi to py, their energies are same. Anti-bonding pi orbital set pi star to px and pi star to py, their energies are same. Why the energies of pi to px and pi to py are same? Because the extent of interaction experienced by 2px orbitals and 2p orbitals is same. Therefore, the decrease of pi bonding orbitals and increase of pi antibonding orbitals is equal. So energetics for resultant molecular orbitals from 2p set will be sigma 2pz, then pi to px is equal to pi to py, then pi star to px is equal to pi star to py, and last sigma star to pz. If we have to distribute electrons in these molecular orbitals, then about the non-bonding kk I discussed, 4 electrons are over, fifth electron will enter in sigma 2s, sixth electron will pair in sigma 2s. Seventh and eighth electron will enter in sigma star 2s. Ninth and 10th electron will enter in sigma 2pz. 11th electron will enter in pi 2px. 12th electron in pi 2py. 13th electron in pi 2px. 14th electron in pi 2py. 15th electron in pi star 2px. 16th electron in pi star 2py, following Hund's law of maximum multiplicity. And 17th electron in pi star 2px will pair there. Why I am considering 17 electron? Because from oxygen 8 electrons are there. You read there 2p4 electronic configuration. And from O minus ion 9 electrons are there. Read electrons in 2p orbitals. There are 5 electrons in 2p orbitals. Total, if you count the number of electrons in O minus, those will be 17. So compared to oxygen, one electron is there in anti-bonding molecular orbital. Anti-bonding means that electron will oppose for the bonding. So let us see bond order What is the formula for bond order? Bond order is equal to number of electrons in bonding orbitals minus number of electrons in antibonding orbitals. How many electrons are there in bonding orbitals? 8. Which are those? Sigma 2s 2 electrons, sigma 2pj 2 electron, pi 2px, pi 2p 4 electrons. And antibonding orbital, how many electrons are there? 5. Which are those? Sigma star 2s 2 electron, pi star 2px 2 electron, pi star 2py 1 electron. So 8 minus 5 divided by 2. Answer is 1.5. So bond order is less than the oxygen molecule strength of bond between oxygen. Oxygen is less in compared to oxygen. How many electrons are there? 1. So it will be paramagnetic or diamagnetic? Paramagnetic. Let us understand its electronic distribution more clearly. Superoxide means O2 minus. See the electronic configuration by blue-green coloration, non-bonding orbitals and electrons are represented. First K, it is the shell from whom? O or O minus? Yes, it is from O, comma. Second K, it is a K from whom? It is from O minus. The comma indicates energy gap is there, energy difference is there. K of O is of lower energy than that of O minus. Then comma, our molecular orbital stars. Sigma 2s, then sigma star 2s, then sigma to pz, then pi to px and pi to py, their energies are same. Then pi star to px and pi star to py, their energies are same, means they are degenerate. And last, sigma star to pz, it is of highest in energy. Electrons are distributed in those molecular orbitals. See, sigma 2s 2 electrons, sigma star 2s 2 electrons, sigma to pj 2 electron, pi to px 2 electron, which has same energy to pi to py 2 electrons. Then pi star to px 2 electrons, pi star to py 1 electron, pi star to px and pi star to py are of same energy. And last, sigma star to pz has no electron. By yellow coloration, electrons in antibonding orbitals are represented. By white color, electrons in bonding orbitals, and by green-blue color, electrons in non-bonding orbitals are represented. That will help us to find the bond order. What is the bond order? 1.5, it is less than that of the oxygen. Here, superoxide ion possesses one unpaired electron, therefore superoxides are paramagnetic in nature. We have discussed the formation of O2 minus from one oxygen atom and one O minus anion. I want to ask you a question related to energies of atomic or ionic orbitals. 2s orbital of oxygen and 2s orbital of O minus. Let us compare. What do you think? Whose energy is lower? 2s orbital of oxygen or 2s orbital of O minus? Write your answer in the comment box. I am waiting for your answers.
Yes, because of execution of charge on any ion, energy levels with respect to atomic orbitals little changes, and that energy levels affects the contribution to bonding or anti-bonding orbitals. So where the electron will more focus, will remain towards the neutral atom or will remain to the ion will be the more clear, and therefore I had given you this kind of approach of molecular orbital theory. Next year the concept will be more clear because you are studying heteronuclear diatomic molecules in detail. You might have come across if electron is added in the anti-bonding orbital, bond order will decrease by 0.5 and bond order for O2 minus is 1.5, decrease by 0.5. Magnetic property paramagnetic because of the existence of one electron. Likewise, let us discuss one more molecular ion for the oxygen, that's a O2 minus 2 peroxo ion in next part.